Welcome to another unit in this Excel course. This time I'm going to talk about simple mathematical operators. Well, for this, let me just put some introductory numbers here and, for example, go with 11 and 49. Well, obviously the easiest operators would be something like plus, minus, multiplication, division. So here, well, most intuitively, for addition, for sums, I use the plus sign. For subtraction, I use the minus sign. For multiplication, division, well, for those of you who did some programming before, it's straightforward as well, because for multiplication, I use the asterisk. And for division, I use the slash. So this works pretty easy as well. However, it becomes a bit more problematic when I'm working with powers, with exponents and with roots. So if, for example, I want to have 11 to the power of 3, I have two possibilities to go with. First off, I can simply write this 11, then I use this type of accent, the accent circonflexe, and write 3. Press OK. This is basically 11 to the power of 3. That's an easy way. This way I can also work with roots or any combination thereof. So if I want to have this to the power of 3 and then the 7th root of this, I can simply go with to the power of 3 divided by 7. That's like 11 to the power of 3 sevenths, or 11 to the power of 3 and the 7th root. Well, as I said, this is one way to work with powers, with exponents. The other way is with a function called power. So here I take a number and the corresponding exponent, and we get the same result. Similarly, if I want to use something for roots, I can also use the function sqrt, which is the square root of any number. As you see, if I go with root, there's nothing there. So here I'm a bit limited, even with here returns the square root of pi. So whenever I want to have more sophisticated roots, I should use this version with the accent. If I want to work with powers, I can also use the power function. For roots, I have sadly only this version of the square root. Okay, so much for working with roots and powers. The next step would be in using exponential functions, logarithms. Here, we actually have only one exponential function, because, well, obviously with the power function, I can simulate anything else which is not the exponential function. So here I can go exponential function to the power of 11 would be this value. If I now turn this around, want to talk about logarithms, here I have actually different options. You already see some here at this point. You see I have the natural logarithm, I have some kind of logarithm, and a logarithm to the basis 10. So let's start if I take the ln of 11 and then take the logarithm to a base of 10 of 11. Now let's have a look what the normal log has. And here, if I use this, you see, I can only enter this, only the value. In this case will always be the log to a base of 10. Or I can enter any which base I want to have. So if I want to have the dual logarithm, simply add a base of 2, get the result here. So that's the most flexible version using log. But I also have the more well-known ln, natural logarithm, and specifically a command for the logarithm of the base 10. And well, this would be most of the stuff you use in basic mathematical operations. In statistics, well, we can have a short look ahead, because there you might come across expressions like this, like faculty of n, or here in this case the factorial of n. It's not written as factorial, it's written as fact only in the English version. So factorial of any number, so here of 11, would be like this. Fact of this number. And well, usually you use this in conjunction with the binomial coefficient. However, this will be introduced in a later session of this course. So here you have more or less all the typical functions you use. We could extend this. However, we might not use this in a statistics context so much, but for mathematical choice, extend this to some functions from the trigonometrical field. Then we, for example, have the sinus function, or as we see down here, the sinus hyperbolicus. We have the cosinus hyperbolicus. We have the tangents hyperbolicus. And if you're looking, for example, for the arctangents or arcsinus, we have arctangents and specific versions of the arctangents. And we have the same thing for sinus and cosinus, and as well you can see here for the cotangents as well. So all the trigonometric functions you might come up with are also similarly implemented into Excel. The only thing to remind yourself of, if it's a hyperbolicus version, add an h at the end. If it's an arc version, add an a in front. Well, that's finally all I wanted to talk about in this session of basic mathematical operators. And well, if you want to see more, perhaps on the details I introduced here only briefly, feel free to visit the rest of the course or have a look at the corresponding playlist. I say goodbye and see you next time.